Welcome to the CHOReOS project demo of the Domain Expert Specification of Quality of Service-Aware Choreographies. Our approach enables domain experts and service consumers, rather than requirements analysts, to express functional and non-functional requirements on services and service-based applications. The aim of the process is to specify and situate the requirements and required qualities in context of the choreography to be modeled. In this process, user task models are used to provide domain knowledge and constraints to inform the choreography design in order to produce a first-cut choreography model. We begin with the Domain Expert tool, which has been developed in Microsoft Excel. First, the Domain Expert identifies service consumer requirements related to a user goal. In our example, this is Find Hotel. There is the potential for us to have many requirements, service needs and service queries from hundreds of users. These requirements contain information including satisfaction scores and quality scores for quickness, precision, robustness, simplicity and security. It is possible to sort the original source requirements, for example those with the highest scores for performance. These requirements need to be grouped in a meaningful way in order to define boundaries for the choreographies and search spaces for the services. The tool enables the domain expert to consolidate these by assessing them for similarity. Once a relevant requirement is selected, for example, what are the best airport hotels here, the domain expert can generate similarity scores against all the other requirements in the dataset. This is done through a similarity algorithm which uses techniques designed to overcome incompleteness and ambiguity in natural language requirements. The domain expert can then add any relevant matches to the selected requirements group. The service consumer needs give us an idea during the design phase of the requirements the services will need to meet. The selected service consumer requirements are added to a requirements cluster. The domain expert can then edit these. For example, a similar requirement for a restaurant review service is changed to one for a hotel review service. Additional requirements can then be added, most usefully functional requirements on the possible interactions between actors. In the next stage, the clustered requirements are matched to a library of generic user task models. To do this, we build on a library of domain-independent models developed in the earlier S-Cube Network of Excellence. When a match is made, the domain expert can then accept or reject the suggested model. In simple terms, each model in the library describes the tasks undertaken by users and machines in commonly occurring tasks such as reserving, purchasing, and traveling. Each embodies important domain knowledge needed to specify a service choreography. In CHOReOS, we use these models to fulfill two important roles. The first role is to specify important constraints on a service choreography. For example, each task imposes important constraints on when subtasks can occur. These constraints inform service choreography. The second role is to link reusable knowledge about the domain in which the task occurs to the requirements on software services to invoke the task. For example, a model might specify the role for a class of software service that a service consumer does not know about or has overlooked. Therefore, by matching requirements to a user task model, our CHOReOS approach can automatically impose important constraints on a first-cut choreography and retrieve candidate services that can fulfill yet-to-be-specified roles in this choreography. Returning to our example of finding a hotel, the model suggests classes of services that may need to be invoked in the choreography: detect current location, retrieve date, retrieve preferences, and retrieve hotel membership details, the latter two being optional. Having submitted the search query, the Enabling with Data Exchange link identifies the end of this choreography task and the start of another to process the query and return results. The choice link between confirm validity and request data re-input denotes a split in the flow of the choreography process. In this case, the user returns to the original choreography task. Finally, the requirements group and modeling constraints are imported into MagicDraw via a CSV file. The functional requirements are represented in a table, which also includes the service classes from the user task model, which are represented as functional requirements. The service consumer requirements are presented in a table for non-functional requirements. The constraints are used to produce a first-cut model. In this case, we have the two identified choreography tasks and a split in the flow denoted by the additional task. The choreography designer will need to use this information to complete the model. For example, The titles of the user tasks can be used to inform the name of the choreography task. The requirements can also be mapped to a choreography task using a dependency matrix. This ensures that the information is carried forward through the design process. So, this completes the domain expert process for providing design knowledge to create a first draft choreography model. We have only looked at 2 particular choreography tasks in this example, but the end result would look more like this complete choreography model for managing an unexpected arrival at an airport.